Okay, friends and neighbors, welcome back. Welcome back. We are working through our CCNA video series, and this is Chapter 17, Configuring IPv4 Addresses and Static Routes, Part 2. So, Part 1 was all about what happens when a host wants to generate traffic, what happens when stuff goes across a router, and a really basic static route topology. Now, we're going to push things a little bit. So, here we go. So in this video, we're going to go on with our network fundamentals topic. I'll remind you about the key topics as well. And we're going to take a look at variations on that static routing. What are all the things that you can do with a static route? What are some good ideas? What are some bad ideas? Maybe a little bit of troubleshooting. And then, of course, we'll do the do I know this already questions. Now, this is the set of key topics. Again, it's a long list, but it's all the things that happen when we want to send an IP packet, right? What does the host do? Process its host routing table. Then we got to look at its ARP table. Then the steps that a router takes when it gets the IP packets. What does it do? And there's those 5 steps that we went over. And then we've got all of these things that are in a routing table. So we introduced those last time, and we're going to exercise those a little bit more this time. And then there are some rules for us when we take a look at how we're going to set up static routes. Okay, so we'll take a look at a little bit of all of these. Now this was our router 5-step summary. Now if you didn't see the part 1, you probably ought to go back and take a look at that. That's unless you already know what you're doing. But if you're confused by anything that I say in this video, take a look at part 1 because we do it right from the host all the way out in that one. Okay, so a router gets a frame, and we're assuming that this is addressed to the router, and if that's the case, then if there are no errors, the router's now got to process the packet. We're going to de-encapsulate the packet, meaning we're going to destroy the frame, take a look at the IP packet, and then we're going to process the router routing table, which will have a series of routes in there and then interfaces to which those routes are connected. And then once we figure out which direction to send this packet, we are going to build a new frame and then transmit it out. So this was really, really the important part. And that's what we did an example on and a demo on last time. I'm going to do another set of demos here, but we're going to push beyond what we did the last time. Okay, so flavors of static route. Now on the bottom here, this part right here, that is the standard sort of static route that we want to see. And there are 3 fields in a static route. We can say, what network are you looking for, and what's the mask that goes along with it, and what is the forwarding router's IP address, or the next hop you're going to use to get to that particular destination. A couple of rules with this next hop, right? It's not you, it's not your router, it's a different router, but one that you're directly connected to. So in this particular entry, what the router that's receiving this command would also have to be connected to the forenet. Now this is a very, very clear way of stating your static route. There's no ambiguity at all about who is supposed to handle this. If we compare this to the one above it, right here, IP route 172.2.0, 255.255.255.0, and then there's an interface right here. Oh my goodness, what happens there? You can get away with this. This is perfectly valid syntax, but it spawns a whole other process. What we're using here now is something called Proxy ARP. So we'll take a look at how this works, but it's kind of crazy, right? The router will actually ARP for a destination MAC address that's on the other side of a router. That's crazy talk, right? It's not normally how it works. You only ARP for folks on your network. But what you're doing when you set up a route this way is you're saying to your neighbor router, please handle this for me. That's great if the router's set up for Proxy ARP. Now, Cisco's do it by default, but you don't know in a mixed vendor environment how it's going to work. And anybody taking a look at your config would not be sure on what in the world you are trying to do. Now, Proxy ARP has a rule, right? If I'm going to send this packet out the same interface that I received it, right? So you send me an ARP request and I got to ARP right back out that same interface. That's kind of crazy, and so Proxy ARP won't work in that. But let's take a look at exactly what's going on here. Now, before we get to the demo, I'll just point out the graphic that's above me here. And we can see that if we do a regular static route, we get a very standard, here's how the network that I'm trying to get to, and here is the forwarding router's IP address, and there is our admin and metric, admin distance and metric. But if we do it this way here on the top, we get a much stranger looking connection. It almost looks like a directly connected route, but of course we've got the static route S out here, which indicates that this is a rule that I have for forwarding. Okay, let's see how this works. Now, just to take a look at the topology, I've got the 1 net here, and I've got the 2 and the 3 net are the remote networks. And then I've got the 4 and the 5 networks. These are the networks that I use to connect to the other destinations. I've used an integrated services router, kind of like we talked about in Chapter 16, and I've added a module here for my interfaces. So that gives me more than just 2 physical Ethernet interfaces. If we take a look at my routing table, and now I've been futzing around with this to save a little bit of time, but if we take a look at the routing table, right, I'll point out a couple things to you. If I want to get to the 2 network, right, now according to router number 2 is directly connected to the 1, the 4, and the 5. And we can see that. We can see the C here, right? I'm directly connected right there. I'm directly connected to the 4 network right here, right? And I'm directly connected to the 5 net. But if we take a look here, the 2 net, the claim is that the 2 net is directly connected, but it's a static route. Okay, so this is where the mystery comes in. So all that I'm going to do, we'll run our simulation here. But all that I'm going to do is from PC 5, I'm going to ping, and it doesn't even have to exist for this to work. We're just going to take a look at how the routers interact. So I'm going to ping 172.16.2.1. Okay, so there's a node out there, but again, it's what goes on in between the routers that we care about. Now we know that the host is going to ARP for its default gateway because we have to send a frame up there. Right? The router says, yes, this is me, I can help you. And the message goes back. Now we're going to send this ICMP message, and out it goes. Now the router, oh my goodness, what's happening here? The router just ARPed. Now normally we would be expecting the routers to ARP for each other because they have to build frames for each other. But now it depends on when we get into the process here. We'll take a look at all of the ones that we need here. But who is this router ARPing for? 2.1. It's ARPing for a node that's on a network that's on the other side of a router. This is unheard of. You normally only ARP for folks on networks that you're sitting on. And so this is the beginning of the proxy ARP. What we're asking our neighboring router to do is handle the forwarding of this particular IP address. And so we're ARPing for this, and we're sending it to our neighbor, and this router 3 here is going to say, oh, I know where the 2 net is. Let me see if I can handle this for you. Now, here's another crazy part. The router responds and says, yep, here's the MAC address for 2.1. But 2.1 isn't even really out there. And so the question is, what is that address? I'm answering back for it. Well, let's see if we can figure this out. Now this interface is G0/0/0. The MAC address of G0/0/0 is 2701. What router 3 is telling router 2 is that I have the MAC address for 2.1. Well, we know that's not true. But what router 3 is effectively doing is saying, I will answer up for this. And so the next thing that happens is that router 2 is now very happy. It believes it knows where 2.1 is. And so this ICMP traffic gets all the way to router 3. And if we now take a look at the ARP table on router 2, we can see that the router itself is answering up for this particular MAC address. Okay, so that is Proxy ARP, right? When you set up a static route that way, where you're just dumping it out your interface, what you're hoping is that another process, Proxy ARP, steps in and handles the forwarding for you. In this case, router number 3 saying, "Yep, I will handle that, and I will answer up for that particular address." Well, now let's talk about a couple of other routes that we can do. The router needs a default gateway or a default route as well, right? Just like a host does, then we can set up a router to have a default route. So if I'm processing the router routing table and I don't find an answer, then the router just says, oh, well, in the case of not knowing the answer, I just always send it to this other neighboring router. And that is the default route. And that is the special case of a static route. And it's very, very common. And again, the reason it works is because anything ended with a 0 gives you a 0. I'll show you the syntax for that here in a second. The other example on this slide for static routes is host-specific or static host routes. And you can see examples of both of those up here. Now, previously, when we looked at the directly connected routes, we saw the routes for the networks, and then we saw the /32s for the router's IP addresses. This is a /32 for a host that's beyond other routers. So here we've got an example of 2.9/32. So this particular router is directly connected to the 1, the 5, and the 4, but we have a host-specific route. Now the nice thing about that is that you can send traffic any direction you want with your routing statements. It just has to work, right? So host-specific routes are just one tool in the tool bag that you can use to direct traffic anywhere you want to. It might also be that you have more than one pathway to get to nodes or things of that sort. Sometimes we use /32s also to get to management interfaces. At the bottom, we can see we've got the special version of a static. Now there's a little asterisk here because this is now a default route for this particular router. So let's take a look at the syntax. By the way, I thought I would show you the show run command. You can see that I've got all of these entries in here. And what I'm going to do is I'm going to get rid of this route here. Well, I'll get rid of both of them and I'll show you how to do them again. Okay, so big T, and I'm going to say no. We'll also get rid of the host specific route. All right, so our routing table is going to be a little simpler now. So here we just have networks and I have no default route. So what I'm going to do is tell my router that you've got some static routes, but I'm going to give you a static route for a default route. But this time I'm going to send it via 5.254. So that's down here. So the way that I would do a default route is I would say IP route, but the destination network here is everybody. So 0.0.0.0. Well, what would be the mask that would match everybody in the ending process? It would be 0.0.0.0. And I would say, well, just who's going to be the forwarding router's IP address for that? Whoops. There we go. And now if I take a look at my routing table, by the way, we'll do the show IP route static, right? We can see that we have that default route right there. Okay, well, let's tell this host that it is, in fact, going to be 2.9. That's the example in the book, I think. And its gateway. All right, so This is 2.253 right there. A router up here knows about the 2net because it's directly connected. Right? So when we look at our tables, we can say, well, can I get there? It's directly connected. What this router doesn't know about is where the one network is. So let's do two things. We'll fool around with this, this host-specific route, and I will say that I'm going to create a host-specific route for just PC5 down here. Now PC5 hopefully should be 1.1. Let's see, did we do this already? We did. All right. So this is 172.16.1.1. And we are going to make this 172.16.2.9. So that's what we need our static routes for. Now, normally we would do networks, right? I would say on router 3, here's how you get to the 1net, and on router 2, here's how you get to the 2net. But we're not going to do that. In fact, if there's anything for the 2 or the 1net, we're going to undo all of that. But we can see right here that there is nothing special. So I'm just going to say IP route 172.16.1.1. Now here's the tricky part. This is going to be host specific or a static host route. So it's a /32. And how do I get there? Well, 172.16.4.253, which is right down here on router 2. Okay. Well, if I take a look at my routing table, I now have this host specific, right? There's the /32 right there. All right. Now, if I ping, this will get all the way down there, but we won't know how to get back. So let's take a look at, so we've got this wonky static route here. So I'm going to say config T. We're going to get rid of that entirely, just to make sure that our host-specific routes work. So I'm going to say no IP route 172.16.2.0. And then we're going to say G0/0/1. So if I take a look at my static routes, it's all gone. Now we have this default route, but we're not going to worry about that because I'm going to add a route for this particular host. So I'm going to say IP route. Well, where are we going? Normally we would be going to a network, but now I'm going to go to 2.9. And again, this is going to be just for 2.9. 172, how do I get there? Well, this will be via 4.254. And there we go. So here is our host-specific route. Well, let's see how this works in the simulation. And we'll ping from up top this time. So I'm going to ping 172.16.1.1. Now we'll see that there will be some ARPing back and forth, right? As everybody figures out their gateways and the destinations. All right, this is looking good so far. So it made it all the way to the destination. And looks pretty good. Well, we got some ARPing to do there where they figure that out. And there we have it. So we're not used to doing it this way, but static routes can be about a whole network, they can be about part of a network, or they can be about your hosts only. Now the last kind of route that we're talking about here, the last kind of static route, I suppose, is a floating static route. Now we already know that if I have interfaces that are down, then the routes associated with that interface will also be missing from the routing table. So on any one of those routers, if I disconnected the links, the routes that were on that link or that were going via that link would be gone. We also know that routers install the best routes. And that'll be dependent upon the prefix length, the admin distance, and the metric. So if I was running a routing protocol like OSPF, and then ran another routing protocol like RIP, and the routers saw entries for all the networks that are out there via both of these routing protocols, they would pick one. Now, assuming that all the networks were the same, they would pick based on the admin distance. And what this also means is that you could have a route that you're using, and then the minute a better route comes along, we stop using this one. And we use this one, but then something might happen to this one, in which case we pop this one right back in there. That's a floating route. So the example in the book is that you're using a connection, but when the connection is gone, you're going to spin up or use this other connection, and then when the cellular link comes back, you use that one again. And that's the whole idea here. So the control is based on the administrative distance. And again, administrative distance is a measure of the quality of a particular method for reaching the destination. Directly connected is the best. Static route is the best. After that, and then it's everything else depending on how you get there. So OSPF is better than RIP, for example. Now, if I have a static route with a really bad administrative distance, if anything better comes along, I won't use that static route until the better route fails. And that's the example in the book. So the idea of prefix length and admin distance and metric, these are important ideas to hang on to as well. Now in the example above here, I did the static route exactly the same, but I used an argument to the static route command to add this metric, or the admin distance. So I changed the admin distance, and you can see that normally it would be a 1, and now it's a 100. So I will show you how to do that, and you can tweak this however you want. And what this means is that you use the static route when there's nothing better around. Now I might also do this, if I was doing a loop or something like that, follow this pathway when nothing else is around. We sometimes do that when we've got a higher cost link. But here's the syntax for it. I'm going to tell, right, we know that the 3net is way down here. So I'll just enter the 3net and show you the syntax on how to do it. But that's all we need for the video. But I'll say IP route. Now normally I would go 172.16. I'm going to the 3net. Here's the mask associated with the 3net. Well, how would I get to the 3net? Well, it would be via 172.16 4.254. Now, that would be fine. I could just leave it right there. But what if there was another pathway that I wanted to use most of the time? And if that pathway was available, I'll use it. And if the pathway wasn't available anymore, I would use this one that I'm entering in here. In other words, I'm using that floating static route. Well, what I would do is I would say, well, is there something I can put in here to indicate that this is a low quality or low value route? And the answer is that I can put something in here like this, right? That's actually a good bit of troubleshooting. This error right here, I forgot that I made this 254. So it has to be, your static routes have to point to somebody that's not you. So I have to use 253. So that's why I got that error. There we go. Now we take a look at my routing table, just the static entries. I can see that I've got this crazy administrative distance right here. And what that looks like in the context of the whole routing table, right? Still there. But that's how you would say, look, I want to put this static route in here, but if anything better comes along, use that instead. So that is a floating static route. All right, did you know this already? Router 1 lists a route in its routing table. Which of the following answers lists a fact from the route that the router uses when matching the packet's destination address? So we have to realize that the packet comes in, and the packet is going to have an IP address. And the router says, all right, which is the entry that I want to use with this? And the answer is going to be A and C, the mask, and then the subnet ID. And so when I AND the router table entry with the mask and the destination with the mask, they should be the same. PC1 sends an IP packet to PC2. To do so, PC1 sends the packet to router 1, which sends it to router 2, which sends it to router 3, which routes it to the final destination. All links use Ethernet. How many routers de-encapsulate the packet from an Ethernet frame during its journey from PC1 to PC2? And the answer was 3, D. They all do it. So remember that every time you cross a router, you're going to be destroying that Ethernet frame. Question number 3. After configuring a working router interface with its IP address and mask of 10.1.100/26, which of the following routes would you expect to see in the output of the show IP route command? Remember that you're going to have one for the network and you're going to have one for the router's IP address. So it makes sense that you're going to have a 10.1.1.100/32, but it also is going to be the network. Well, what's the network with this particular mask? Well, it turns out it's a .64/26, not .100/26. So A and D. Which of the following pieces of information could be listed in a correct IP route command on a local router? Well, you know you're going to have the next hop router, right? You can have that. And then we saw that we could use that interface command or interface argument as well. Question number 5, which of the following commands correctly configures a static route? Well, there was only one that made sense of those, and that was the standard static route, the preferred static route methodology. Right? Stay away from those proxy ARPs if you can help it. Question number 6, a network engineer configures the IP route 10.1.1.0.255.255.255.0 going out over a serial link command on a router and then issues a show IP route command from the enable mode. No routes for the subnet appear in the output. What could be wrong? Well, if your link is not up, you're not going to see the that route. So B, that the serial link was down. All right, the quick look ahead. More exciting ground to cover as we look at routing in different scenarios, especially with VLAN. So that's what Chapter 18 is all about. We've got some switch virtual interfaces there. So VLAN routing with switch routed ports and the router's LAN ports, right? You can put a module in a router that gives you the switch ports. So going to be some very interesting and fun stuff in Chapter 18. So this was Chapter 17, Part 2. Oh, so many static routes, right? Static routes with interfaces and a next hop. We did default routes, floating static routes, host-specific routes, and, of course, lots of demo fun. Well, like and subscribe if you found this video illuminating and perhaps even a little entertaining. And we will hit Chapter 18 is next up. Well, that'll be it for this one. May those packets always reach their destination, no matter what you've tried to do with your static routes. And this is CCNA. You can do this.